Okay, so let's learn about the types of reactions. So, types of reaction. Um, there's more reactions than we're going to go through. However, they're a little more advanced, and you're not going to really study them till later grades. So these are kind of the simple reactions that we're gonna look at. Okay, so we've learned balancing already, and once you go through this, you'll learn as you're balancing to recognize these reaction types, and you'll do some work with actually stating what type of reaction it is after you balance it. Okay, so the first type of reaction that I want to talk about is a synthesis reaction. Synthesis. Does anyone know what the word synthesis means or refers to? Have you ever heard the term like synthetic? What does that usually refer to? Okay, yeah, generally we use that in terms of man-made, but I think the root is more to do with like creating something or making something or putting together. What was that? Photosynthesis means putting together with light. So we're taking carbon dioxide and water, and you're synthesizing glucose. So yeah, that's another good use of the word synthesis. So it means putting together, essentially putting together. So usually when you see the word synthesize, it means that something has something to do with putting something together. So one general equation for that, so a general equation for this is something that looks like this. Reactant A plus reactant B makes reactant or compound AB. Okay? So that's a general equation for synthesis, and hopefully you can see why that's synthesizing. We're taking two separate things and making one new whole, right? So an example that we've seen of this is maybe something like this. We burned magnesium with oxygen, and we made magnesium oxide. Is that a balanced equation right now? So if I do this and this, I should be good. Okay? Do you see how that follows the general equation A plus B equals AB? There's A, there's B, and there's AB, creating a new compound. Can anyone think of another synthesis reaction that we saw in here recently? I'll give you a hint. It involved two gases. Tom, what do you think? Hydrogen and oxygen to make water. Yeah. So we generated some hydrogen a little while back and ignited it in the atmosphere, which contains oxygen, and we created water. Okay? And I think we had to do this and this, and it should be balanced. Okay? So two synthesis reactions, putting together. With me? All right, sweet. What do you think the opposite of putting together is? Taking apart. Does anyone have an idea of a word that means to take apart or to fall apart? What's that? It's not separate, but it means separate, and I mean you'll recognize it as something separating. What happens when time passes to, like, say, dead organic matter? What do we say happens to it? Decomposes, and that's what this reaction is called. It's called decomposition. So decomposition is essentially just the exact opposite of synthesis. So you're going to have, oops, let's change the color. You're going to have something like AB reacting to form A and B. I'll show you an example of one that we're going to do as a demonstration tomorrow. So it looks like this. Peroxide. And it'll fall apart into H2O plus O2. Is that balanced? What do we got to do to balance it? To there, but then what happens? We good now? 4, 4. Yeah, okay, good. Balance there. This is generally a liquid, and a gas. Okay? We're going to look at this reaction tomorrow. And if you want to look it up online, it has a name that I'm sure you will remember, and that is elephant's toothpaste. So if you want to ruin the surprise, you can YouTube elephant's toothpaste. If you want to like save it for tomorrow, I highly recommend it. Okay. Number 3 is going to be called single displacement. Although some people call it single replacement. I think there's 2 of these, and they're pretty easy to remember because they just essentially say exactly what they do. So let's say you have something like this. You might have some silver chloride, and you might say have another metal like, I'm going to say copper. And if you react these in the right way, what you'll end up with is silver and some copper chloride. What does AQ mean again? Aqueous. Aqueous. And what does that mean about this ionic compound if it's aqueous? It's dissolved in water. Liquidated is an interesting way to put it, but yeah, if that helps you remember, sure. Oh, you know what I forgot to do? I forgot to show you the general reaction. See, so we're doing this in reverse order. So the general reaction here is A, B plus C gives me A, C plus B. Okay, so one of these is replaced. Okay, so single replacement. Is this balanced, by the way? I think that's good, isn't it? Yeah, that's right. So there's a single replacement or single displacement, right? One of these is kicked out and is replaced by the other. Does that make sense? It's pretty self-explanatory, I think, in the name. The 4th kind and the second last kind, actually there's 2 more, sorry. This is double displacement. Try to do this in the right order this time. Does anybody want to hazard a guess as to what this would be? Yeah. Okay, so double displacement, as we heard from the audience, is when 2 compounds switch partners. So let's say we have AB plus CD. You might get something where you now have AC plus BD. Okay? I'm just going to pull an example off the top of my head here. See if I can think of one that would actually happen. It's a lot tough. Well, you know what? I'm not sure if this will actually happen, but just for the sake of having something to put, let's try this. What's this called, by the way? Lead. Now, lead is a transition metal, Tyler, so what do we have to say after lead, Tyler? What do we have to say after lead? We have to say a number, right? Lead what? Lead 4. What's this called? Nitrate. Exactly. Lead 4 nitrate. So from that, we'll get silver nitrate. Yeah, I'm pretty sure this probably won't happen, but whatever. And then PbCl4. Now to balance this guy, do this and that, and I think that does it. Okay. aqueous for all of these. There's a double displacement, a sample double displacement. Whether it would actually happen in real life is sort of irrelevant. What we just want to see is what is an example where we have these partners changing. Okay. The next kind that you will see is a combustion reaction. So these are quite common. You know, anytime you're burning something, it's undergoing a combustion reaction. In fact, even cellular respiration is a sample of a combustion reaction. Combustion reactions are a little bit different. They're not in the same frame as this. So basically it works like this. You have a carbohydrate, or really just like any carbon-containing molecule. Maybe I shouldn't say any carbon-containing molecule, but a molecule containing carbon. And you combine it with oxygen, and its products are water and carbon dioxide. Okay? So you know you've got combustion when one of the inputs is oxygen, and the products are water and CO2. Okay? If that's happening, you have combustion. So let's do a sample of combustion of methane, say, since we talked a little bit about methane before. Okay, so here's methane, also known as carbon tetrahydride, and it's going to react with oxygen. We said we should expect the products of this to be CO2 and H2O. Okay, so let's look at balancing this. So we need we need more hydrogens over on this side. Put a 2 over there, and that gives us 4 O's. So if we put a 2 there, I believe we're balanced. Okay? This is a sample of a combustion reaction. Sometimes people will try to call this something like a single displacement or something like that, but you can see pretty clearly it doesn't really fall under the categories that we've learned about before. It's sort of its own type of category of reaction. Okay? These can be pretty complicated. As I'm sure when you're doing your balancing reactions sheet, they're going to stick a lot of combustion reactions in there. Sometimes the carbohydrate has oxygen in it as well, and sometimes it's just carbon and hydrogen. So there you go. There's a combustion. When you burn something like paper, you have like long chains of carbon-containing molecules, and they burn away and they produce CO2 and H2O. When you're driving your car around, okay, you're inputting basically a blend of hydrocarbons. I should probably call these hydrocarbons. That's probably a better word for them. Carbohydrate sort of implies something different. Hydrocarbons is a better way to say it. Hydrocarbons. Okay, so when you drive around in your car, or you're burning coal or whatever, or even wood, you're essentially burning hydrocarbons, and these are the byproducts. This, by the way, is the main culprit today for global warming. Okay, and last but not least, we're not going to go into this yet because we haven't taken what acids and bases are, but I'm just going to mention it because we'll come back to it later. So the last kind is acid-base neutralization. Okay, and the inputs are the acid and the base. And an output is a salt and water. And that's not going to make a lot of sense to you right now, and that's fine. We'll cover it later when we do acids. Are there any questions? All right.